Previously on Random Things Mr. Kelly starts his videos with.
And at the heart of these problems lies one of the central themes of mathematics: how to solve equations. Equations are a little bit like cryptic crosswords. You're given a certain amount of information about some unknown numbers, and from that information you've got to deduce what the unknown numbers are. For example, with my weights and scales, I found out that one plum, together with 3 peaches, weighs a total of 15 grams. But 2 plums, together with 1 peach, weighs a total of 10 grams. From this information, I can deduce what a single plum weighs and a single peach weighs, and this is how I do it. If I take the first set of scales, 1 plum and 3 peaches weighing 15 grams, and double it, I get 2 plums and 6 peaches weighing 30 grams. If I take this and subtract from it the second set of scales, that's 2 plums and a peach weighing 10 grams, I'm left with an interesting result: no plums. Having eliminated the plums, I've discovered that 5 peaches weighs 20 grams. So, a single peach weighs 4 grams. From this, I can deduce that the plum weighs 3 grams.
Today we're going to look at solving equations with variables on both sides. Our objective is to take these equations where we have variables on both sides and reduce them down to a 2-step equation that we know how to solve. Now, in that video you watched, which was from a documentary called The Story of Maths, it is a British documentary. That's why it is called Maths, plural, instead of math. That's how they refer to it over there. But in that video you saw how algebra can be used in that situation involving the weight of the fruits to find out the weight of one thing when you know both. And what had to happen was that one of those had to be eliminated. It had to go away. We're going to look at a very similar situation here. We already know that we can reduce complex things to 2-step equations by simplifying, distributing, combining like terms. But we had this limitation that we cannot combine like terms across an equal sign. So for instance, if I have this equation right here, these 2 parts that I've put in the boxes are 2 expressions that are set equal to each other. I cannot ever cannot combine like terms across there. I can't combine the 3x and the 5x just by adding them. They both appear to be positive. I cannot do 3x plus 5x. That equal sign is a wall that cannot be breached. These 2 expressions cannot talk to each other that way. We have to look elsewhere. And just like in the video where you saw him set up a situation where the plums were removed, we're going to set up a situation where I can take one of these variables, either the 3x or the 5x, doesn't even matter which, and I'm going to eliminate it. I'm going to get rid of it. And we already know how to eliminate things, terms, from one side of an equation or the other. We've already looked at that. So we eliminate these terms by either adding or subtracting using the inverse operation. So for instance, if I have this problem right here, I can get rid of either the 3x or the 5x just using inverse operations. Let's get rid of the 3x. If we get rid of the smaller one, we can avoid some unsightly negative signs. So this is a positive 3x. Remember, if there's nothing in front of it, we can pop a plus sign in there. It's no big deal. So to eliminate this, I would use the inverse operation, which is subtraction. And so I would have to subtract 3x from that side. Well, whatever I do to one side of an equation, you'll recall I have to do to the other. And when I do this, I can combine like terms over here. Plus 3x minus 3x. Well, those are inverse operations. They cancel, leaving me with a 2. 5x minus 3x. Remember, I have to combine like terms now that I have these 2 x's over here on this side. 5x minus 3x would be 2x, and then my minus 10 just comes along for the ride. And look what has happened when I did this. When I eliminated a variable from one side, just like those plums were eliminated in the video, what happens is I end up with all my variables on one side, and in this case, without any further work, ended up with a two-step equation which we know how to solve. So I've now taken this complex equation where I have a variable on both sides and turned it into something that we know how to work with. This process I will refer to as gathering the variables, because before I had a 3x right here, a 5x right here. I had variables on both sides. But after I gather the variables, all my variables are in one place on one side of the equation. So let's look at an example. We've got here 5x plus 12 equals 3x plus 22. Now I notice I have variables on both sides. There's no distributive property I can do on either. There's no combining like terms I can perform on either. So the first thing I'm going to do is gather my variables. I want to either eliminate the variables on this side or on this side. And interestingly enough, it does not matter which side I gather the variables to. If I gather to the side that has the smaller coefficient, I end up with a negative number generally. And if I gather to the side with the larger one, I usually end up with something positive, which is kind of what we want. So I've got a 5x and a 3x. I'm going to eliminate the smaller of those two, which is the 3x. There's nothing in front of that 3x save an equal sign, so this is positive 3x. So to eliminate that term, I'm going to subtract 3x from both sides. 5x minus 3x is, of course, 2x plus 12 equals, now on this side, the 3x and the minus 3x cancel out. I've eliminated one of those variables, and I'm left with just 22, and you'll recognize that this is just a two-step equation. I have multiplication, I have addition. Let's get rid of the addition first, using inverse operations. So here I get 2x is equal to 22 minus 12, which is 10. Now I have to undo multiplying by 2, so I would divide by 2, and lo and behold, I find that x is equal to 5. Notice I've presented my solution in terms of the variable is equal to, and I can also check my work by substituting back in. 5 times 5, if x is indeed 5, 5 times 5 is 25. 25 plus 12 would be 37 on that side. Over here, I do 3 times 5, that's 15. 15 plus 22 is 37. When I substitute in my solution, I get a true statement. It is indeed a solution. So x equals 5 is going to be my answer. Here, I have the same thing, except this variable doesn't have a coefficient. So remember, that's like having a coefficient of 1. I want to gather my variables. There's no distributing, there's no combining like terms that I can do. And in this case, I'm going to gather the variables over to the right-hand side of the equation. The reason being, this has a larger number, and so I want to gather to the side with the larger number. So to get rid of 1x, it's a positive 1x, I'm going to subtract x from both sides. This leaves me with a negative 9. Notice that negative sign stays with the 9 on one side. 4x minus x is 3x, and the 18 just comes along for the ride. Now I have my variables gathered to one side. They're only on one side of the equation, and I have a nice two-step equation I can deal with. So I get rid of the addition by subtracting 18 from both sides. Negative 27 is equal to 3x. I need to isolate my variable, so in order to do that, I'm going to divide by 3, and I find that my solution is x equals negative 9. Up to this point, the problems that we have solved have all involved variables on both sides, and then when we gather the variables, magically we have a two-step equation. It's not always that simple. Sometimes we're going to have to simplify before we can even gather the variables. So remember, simplification is the combining like terms and using the distributive property. So I have to look and see if I can do that before I move on. So in this example, you can see I have a very complex equation here. On the left-hand side of the equation, this expression, I cannot use the distributive property. I cannot combine like terms. But on the right side, I have distributive property and combining like terms. So we need to do that first before we even gather the variables. So I have to take this -2 and distribute it throughout. And when I do that, I have -2 times 1. I have -2 times positive 5b. And then from that, I am subtracting 5b. Now I'm going to put this distributive property stuff together. This side remains just 38 minus 5b equals now -2 minus 10b minus 5b. Once I've done that, I can see I have like terms to combine here and here. And when I do that, I end up with still 38 minus 5b on one side. But on the other side, I get -2 minus 15b. Now I have a situation where I have variables on both sides. I'm going to gather the variables to the larger side. -5 is larger than -15. Remember, if it was on the number line, -5 would be farther to the right. So I'm going to add 15b to both sides. And when I do that over here, I can now combine these two like terms. I get that 38 is not equal to, excuse me, misplaced equal sign there. 38 plus 10b is equal to, and then over here, all that I'm left with is my -2. Now it's a two-step equation. I can solve by subtracting 38 from both sides, leaving me with 10b equals -40. And then, of course, my last step is to divide by 10 to eliminate that coefficient. And I find that b is equal to -4. Notice that's a lot of steps and a lot of things to write down. When you work these problems, I fully expect you to write down every single step and show every single step. There are too many places to get lost. If you write it down, that frees up space in your memory to work on the problem. On this one, example 4, we now have distributive property on both sides, and we'll be able to combine like terms afterwards on the left side. So let's just go ahead and get this distribution party started. I have 3 times -4, and then I have 3 times positive 5n, and then I'm adding 6. And over here I have -4 times n, and then -4 times -8. And I got to put all that together. 3 times -4 is -12. 3 times 5 is positive 15n. Remember, I'm letting my sign of that answer go into the problem as a plus or minus sign. The 6 stays the same. -4 times n is -4n. -4 times -8 is plus 32. Now over here on this side, I have 2 constant terms. Remember, a constant term is a term with no variable. I have 2 constant terms over here, and I can combine them. -12 plus 6 is -6. Feel free to use a calculator on that. There's no reason not to. Over here on the right-hand side, there is nothing to combine, and now I'm free to gather my variables. 15n is bigger than -4n, so I'm going to gather them all to this side, which means I eliminate that -4n by adding 4n to both sides. It's 4n, rather. So I get -6 plus 19n equals, these cancel, and I get 32. Now my two-step equation becomes obvious. I can add 6 to both sides, and I find that 19n is equal to 38. And when I divide by 19, I find that n must equal 2. And again, I can substitute that value back in to confirm that that is in fact the correct answer. And I've shown all my steps, no matter how painstaking that might be. Now, here's where it can get weird. Sometimes we're going to simplify both sides, gather the variable, and our variable is going to disappear on us completely. So here is the situation so that you can see it. The 4x minus 5 just stays the same. There's nothing crazy going on there. I distribute the 2. 2 times 2x is 4x. And then I add 2 times 1, which is 2. Now I'm going to gather my variables. 4 and 4 are equal, so I'm just going to subtract 4x from that side. What I do to one side, I have to do to the other. And watch, 4x minus 4x, they're inverse operations. They cancel. So I have negative 5 equals 4x minus 4x. They're inverse operations, so they cancel. And my variable entirely disappeared, leaving me with just 2 numbers on either side of the equation. Now, one of 2 things is going to happen. If the variables are eliminated and what remains is a true statement, something like 3 equals 3, negative 5 equals negative 5, then we're going to say that our answer, our solution, is that there are infinitely many solutions. This equation, if it gives you a true statement, is going to be true no matter what number we use for the variable, which means we can use any number for the variable. These equations are called identities, and the reason is that if you simplify enough on both sides, you'll find that the 2 sides of the equation are identical. They are exactly the same, and so it doesn't matter what number you use for the variable, they will always come out to be true. So if your variables eliminate and you get a true statement, you have infinitely many solutions. If you eliminate the variables completely and what's left is false, like negative 5 equals 3, then the equation has no solution. No matter what number you put in for the variable, you can never ever make that equation true, so there is no number that can ever be a solution, and indeed there are no solutions. So note that this is different from saying 0, because 0 would be a number that would be a solution. So it's not that there is a solution of 0, but there are no solutions. There are 0 number of solutions. Again, no number can ever make that true. So let's look at some examples of these types of problems. Here I've got 4y minus 5 equals negative 5 times negative 3y plus 6, in parentheses, minus 11y. So let's distribute, because we know we need to do that first. Negative 5 times negative 3y would be positive 15y. Negative 5 times positive 6 would be minus 30 minus 11y. Now I have like terms that I can combine here and here, so I will do that. I get 4y minus 5 equals now 4y minus 30. I'm going to gather my variables. They're the same size. So I'm going to eliminate from the right-hand side just because 4y minus 4y is 0. Those go away, leaving me with negative 5 equals 4y minus 4y. Those cancel out, so that leaves me with negative 30. And my variables have completely eliminated each other. They're gone. And I'm left with a statement that is not true. So what this means is that it doesn't matter what number I put in for the variable, this equation will never ever be true, which means there is no solution. There is no number I can ever find that will make this equation true. On the other hand, are equations like this. I have 3 times quantity negative 2x minus 2 equals negative 6 minus 6x. So I'm just going to distribute. 3 times negative 2x is negative 6x, and then 3 times negative 2 is negative 6. And then on the other side, everything stays the same. Now, take a look at this before we do anything else. Here I have a term of minus 6. Here's a term of minus 6 on the other side. Or minus 6x, excuse me. Now I have a term of minus 6, and here's a term of minus 6. This is an identity. Even though their order is flipped, I have the exact same things on both sides. But let's go ahead and see what happens if I try and gather my variables. Same side, so I'm just going to undo the subtraction over here. Negative 6x plus 6x is 0. Those cancel, and I'm left with negative 6. Over here, these will eliminate each other, and I'm left with negative 6. And so this is true. Negative 6 is equal to negative 6. So it doesn't matter what number I substitute in for x. Anything, literally any number, will work. And so I would say that this is going to be infinitely many solutions. Excuse me. So infinitely many solutions, which tells me that I can use every single number possible. Another way of saying this that you may see occasionally, and you'll saw that I started to write there, is you can say all real numbers as well to indicate that you can use any number you want to, or if you want to get super awesome sauce fancy, there's a symbol for all real numbers that looks like an R with an extra vertical line on it. Let me draw that a little bit better. So it ends up looking like this. And that R indicates all real numbers. You can use whichever you like. So to wrap this thing up, if I have variables on both sides, I need to eliminate the variable from one side or the other, and this process is called gathering the variables. But before I gather the variables, I have to simplify. So for this problem right here, that means using the distributive property to get negative 8x minus 12 minus 5 equals negative 3x minus 7. And then from there, I have to combine like terms if possible, so that I would get, in this case, negative 8x minus 17. And then I have to gather my variables. Take whichever one is larger, and we're going to gather the variables to that side. Negative 3 is larger than negative 8, so I do the opposite of negative 8. I add. And what I do to one side, I must do to the other. These are a pair of inverse operations, so they cancel, leaving me with, in this case, 5x, is that correct? Yes, 5x minus 7. And now, what I'm going to do is I am going to take this two-step equation and solve it by adding 7 to both sides. Negative 17 plus 7 would be negative 10 equals 5x. Divide by 5, and I end up with the fact that my variable is equal to negative 2, which is my solution.